Okay, how's everybody doing today?
Good.
Good? Cool. Okay, so today we're going to start with a review of assemblies. Remember, we talked about assemblies last time. So we'll talk about how we created an assembly file, we created parts, and then we constrained the parts together. And then we'll go on to our main topic for today, which will be a lecture about 3D printing. So we'll talk about what that actually is, some of the benefits and drawbacks of 3D printing, a few use cases where 3D printing is used in the real world, the three main types of 3D printing, which are SLA, SLS, and FDM, some of the materials that can be used, and then how we actually make 3D parts. So basically, we start with the 3D design, we load the part onto the 3D printer, we slice the part, and then we actually print it. And then we'll go on to a preview for today's lab. And for today, you're actually going to design a name tag for yourself that can be printed on our 3D printer, and then we're actually going to print it. So there probably won't be room for everybody to 3D print their name on the printer today, but you should all design the name tag today, and then we'll get some of those prints started right away, and then we can do the rest of them next time. So, so when you're all done, you should have your own little name tag that you can take home and show your friends. So it should be pretty cool. So yeah, any questions before we get going? Okay, cool. So then let's start with a quick review of assemblies. So assemblies are these files in Inventor where you can take two or more parts and put them together. So we did an example where we made a little model car. So we had three different components. We had the body of the car, the axle, and then the wheels. And we put those all together into one model that was an assembly. So the basic process for doing that was we started by creating an assembly file, which is just kind of a container for these other parts. Then we created the parts themselves. And then we did something called constraining the parts. So remember, a constraint was a rule that we told the computer about how we want those parts to stick together. And there were lots of different types of constraints that you could have. You could have one where, parts were just kind of stuck together like this. The ones that we used for our car were insert constraints, where we had one thing inserted into something else. So in this case, it was an axle either inserted into the car or into the wheel. So that held the wheel in place next to the axle, but it still allowed the wheel to rotate around the axle. Okay, so that's basically how we create those assemblies. We create a part, and we constrain several parts together. So any questions about the assemblies? All right, so then let's go on to our main topic for today, which is 3D printing. So what is 3D printing? Well, another name for 3D printing is additive manufacturing. And basically, 3D printing or additive manufacturing, is this process where a machine will build up a part layer by layer. So let's say that you wanted to create a mushroom. So you know that you want your mushroom to be shaped kind of like this. So if you're going to 3D print it, the way that works is that you send this file to the 3D printer, and then the 3D printer prints it one layer at a time. So it'll print the bottom layer first, and then the next layer on top of that, and then the next layer on top of that, and so on. And it keeps going until you build your entire shape. Okay? So that's what 3D printing is. Now, there are some benefits and drawbacks for 3D printing. So some of the benefits are that you can have really wild shapes that are difficult to make with other processes. So like you could make, like you can imagine one of those pasta noodles that that's kind of spiral shape. You know, it's a circle at the top, and it's kind of spiral shape, goes around and around. You could make a you could make that sort of shape on a 3D printer without too much trouble. This would be really hard to make using a mold, for instance, because there's this hollow internal part that that a mold is usually two halves that stick together, and so when you pull them apart, they have to. There can't be kind of any curved bits. Anyway, 3D printing can have all kinds of curved bits and hollow parts inside and things like that. So it can do some really wild shapes, there's a relatively short amount of time between when you create your design and when you get the part off of the printer. So, you know, I could make a design and then have a part within minutes to hours, depending on how big and how complex the part is. So that's a really short cycle time. So that's really good. So those are the main benefits to 3D printing. You can have these really wild shapes that you can't really make with molding, or even with CNC machines. So there are milling machines and things like that that can cut parts, but they also can't cut these internal shapes, and they have a harder time with weird curves like that. So 3D printing can make these really wild shapes, and then it can also have a very short cycle time. So those are the main benefits to 3D printing. But there are definitely some drawbacks as well. So some of the drawbacks are that if you're trying to make a lot of parts, this is a relatively slow process. So compared to like a mold that can make 100 parts at a time, this is relatively slow. And it's also relatively expensive for each part if you're comparing it to making, say, 100 parts in a mold. So this is not great for mass production. So it can do these really weird, wild shapes, and you have a quick cycle time for one part, but it's not great for mass production because it's relatively slow and expensive. Okay. So any questions about the benefits or drawbacks there? All right. That being said, there are definitely some important use cases for 3D printing. So the first one you might think of is rapid prototyping. So if you are designing something and you want to get a part and try it out real fast, 3D printing is great for that. And that, in particular, that relates to robotics. Okay, so if you are working on a production line and you have a robot, and you want that robot to grab onto a little test tube, say, that's on your production line, you might want to have a little gripper that's very specific to that test tube, that fits exactly around your company's specific test tube. You're not going to be able to go out and buy that kind of gripper off the shelf because it's particular to your company. So you need to make that. So you would probably design and make a prototype for that on a 3D printer. So you could try that out. And that little 3D printed part might actually be strong enough to work as the gripper forever. So you could do a very custom part for your specific application, and it might work. And even if that little part is not strong enough to work forever, it would be a good proof of concept that your design will work for your parts. Okay, so rapid prototyping is very useful, especially with robotics. there are also other applications where you need longer term parts, but those parts still can't be bought off the shelf. So things like medical applications, including prosthetics and dental parts. So if somebody needs a prosthetic limb, that limb needs to be specifically tailored to their body. You're not going to be able to go to Walmart and buy one of these things off the shelf. It needs to be specifically made. So 3D printing is good for that because it can be tailored specifically to that person. This is especially true for children and for people who might not have enough money to afford like a custom carbon fiber limb or something like that, because 3D printing is much less expensive than molded carbon fiber. And also with children, they're growing, and so their bodies are changing all the time. They need to have their prosthetics constantly updated. And in addition, they might want something unconventional. So I heard this story and I love it. Somebody was designing a prosthetic hand for a young girl, and they got it fitted to her body, and they got the fingers and the basic stuff there. And they asked her, well, is there anything else that you might like on this hand? And immediately she said, a bubble wand. She wanted a bubble wand designed onto the hand. And they could do it, right? Because it's relatively simple shape and it's easy to do. So this girl got this custom hand and it had a bubble wand attached. So that's just not something you're going to be able to go out and buy, right? So 3D printing is really good for that. And also custom things like dental parts. So the inside of everybody's mouth is different. If somebody needs a custom dental part, it's going to need to fit to their mouth exactly. So 3D printing is a good way to make one-off parts like that, where you don't have to make a million of them, but it can be very, very custom. So that's another use case. Also, certain high-performance machines might need very specific parts, and these machines can include things like race cars, like Formula One race cars. So they might need a specific part for their motor, right? That's the only version of that motor in the whole world. They need a part that's got this crazy bend or curve in it. 3D printing might be able to do that where other processes couldn't make that shape. So things like that. Jewelry is another use case. So it's possible to print in metal in some cases, but also you can print in plastic and then use that as a form for something called a lost wax casting. So you make that form and then you pack sand around it, and then you pour molten metal in, like molten gold or something like that, and it melts away your form, but it takes the place of that 3D printed part that you made, and then the metal cools in that shape. So I actually designed my wife's engagement ring that way. And I sent it to a jeweler, and the jeweler made it for me. So this is a really cool thing. Again, it's a custom part. It's a one-off thing. You don't need to make lots and lots of them. So you can really make it exactly the way you want. So jewelry is another use case. And then finally, things like space missions, things where somebody might need a tool, but they don't know exactly what they need ahead of time. So maybe the mission, carries up all the tools they need, but then they accidentally lose a wrench out the airlock, and they can't get it back, right? They can't just go to the hardware store down the street and buy a new one, right? They're up there in space, they need this tool, and it's gone. So what they can do is they can bring this 3D printer along and print themselves a new version. And this is useful because they don't know ahead of time which tool they're going to lose, and they need to be able to, they don't want to bring up, 10 spares of each one because they don't have enough room and it's just too heavy and too expensive to do that. So they can bring up this 3D printer and then print the one that they need when they need it. Okay, so those are a couple of use cases for 3D printing. Again, it's specifically good for custom parts where you don't need to make very many of them. So, questions about the use cases? All right. So then let's talk about some of the different types of 3D printing. So there are three main types: SLA, which is stereolithography; SLS, which is specific laser sintering, I believe, selective laser sintering, and then FDM, which is fused deposition modeling. So SLA is stereolithography. So stereolithography was the first kind of 3D printing, and basically what happened was, the way that it works is that there's a little projector up here on an arm, and then underneath it there is a vat of rosin. And this rosin gets cured by UV light. So what happens is that this projector shines down an image of the first layer into this vat of liquid, and that cures the top layer of liquid into that shape. And then the vat gets raised up a little bit, and then the projector shines down the image of the second layer, and then that layer gets cured on top of the first layer, and so on. And you build up layers that way by projecting down UV images of the shape of each layer. Okay? So that's how stereolithography works. That was one of the first 3D printing techniques that became available. And that is great for very, very fine details. You can make very, very thin layers, and they come out very smooth. Some of the drawbacks for that are that you have to have this vat of chemicals that's usually pretty toxic, and smells kind of bad, and I think that is a relatively slow process. So, but that was the first process, stereolithography, or SLA for short. The second process is SLS, which is selective laser sintering. So that is where you have a laser that's shining down from above, and you have a sort of a reservoir of material down here at the bottom. This is usually dry material, so it's like a very fine powder. And then what happens is that the laser beam shines down, and it creates a picture of the first layer, and it's hot enough that it actually melts the material that it's shining onto. Let me get this out of the way. So this laser beam melts the little beads down here, and they melt, and then they reform, they re-solidify into that first layer. And then typically there's some sort of a mechanism that pushes another very fine layer of dust over that first one, and then this laser beam comes down and melts that second layer, and so on, and it builds up parts that way, layer by layer again. So some of the advantages to this are that you can still get pretty fine detail, and you can use a wide variety of materials. You can get relatively smooth surfaces. They're a little bit rougher than SLA, but they're still pretty decent, and there are not a lot of layer lines there in the final product. But the drawbacks are that, yeah, this is still relatively slow, and you still have to deal with kind of a messy situation where you've got this big container full of dust or fine particles. So that is the SLS, or selective laser sintering. Okay. And then finally, you come to the last one, which is FDM, which stands for Fused Deposition Modeling. So this is the most common type of 3D printers today. This is the type that we have. This is used especially in hobby situations. Fused deposition modeling is a process where you have a long strand of filament that goes into a printer head, and then this printer head heats up and melts the filament, and the printer head moves around and deposits that melted filament into the shape of each layer. So it basically goes around and squirts out the shape of one layer, and then moves up slightly and squirts out the shape of the next layer, and that's how it works. So that's the most common type of 3D printer around today, mainly because it's relatively fast and relatively inexpensive, and you don't have those messy bins like we have with the other types of 3D printers. Okay? So those are the three main types of 3D printers. Are there questions about that? All right. So then let's talk about some of the materials that we can use. So common materials to use with 3D printing are plastics. So there are things like nylon and things like that. A common plastic that's used with FDM is called SLA. So plastics are very common. When you're talking about stereolithography, this is usually some type of resin that's cured with UV light. But there are many other types of materials that can be used with 3D printers as well. So you can have things like rubber. So you can 3D print rubber shoes, in fact, that are tailored to people's feet. So that's common. You can also have additives that are included with your material. So you can have things like carbon fiber mixed in with your plastic, and that can help to make your prints stronger. And then you can also include other types of metals or materials, such as metals. So especially with the selective laser sintering and the fused deposition modeling, you can include metals in your parts. So with the selective laser sintering, you can actually have a fine metal dust here, and you can have a laser that is powerful enough to melt that metal. So that's one thing. With the FDM, typically the hot end is not hot enough to melt metal itself, but what it will do is you can have a filament that has little tiny metal granules mixed in with it. And so you can print your part in the normal way, and the plastic goes down with those little tiny metal particles embedded inside of it. And then afterwards, you can use a process called sintering, which is basically where you bake that part for a certain amount of time in an oven. And what that does is that melts those little tiny metal particles that are inside of that filament, and those particles melt together and they fuse with each other, and they become a semi-solid structure that way. So you print out the shape, and then you put it in the sintering oven afterwards to melt those particles and make it stronger that way. Okay, so yeah, so there's some pretty amazing materials these days. So any questions about the materials for 3D printing? Okay, so then let's talk about how we actually make our part. So the first step in making a 3D printed part is the 3D design, and that's what we've been doing the last couple of days. So now you're a little bit familiar with that. So you design a part in a CAD program, and then you load that part into the printer software. And that usually has a representation of the printer bed, and you can move that part around to wherever you want it to be on that printer bed. That way you can put several different parts on the bed at the same time. After you've loaded it, then it's time to slice the part. So this is actually a relatively complex process. So what this slicing does is that it takes your model, which might be a big solid part, and it gets it ready to be 3D printed. And so the first thing that it does is that it usually looks at your part and sees whether it can, how it can print it without having to do just a gigantic block of plastic. Because if you were to print just a gigantic block of plastic, it would be really heavy and it would be wasteful. You don't usually need that much material. So when you see a 3D printed part, even if it looks solid, the inside is typically mostly hollow. And so the slicing is where that happens. So the slicing program will look at your part, and then it will try to make it into a shell and a hollow inner part. Now the inside will be mostly hollow, but it won't be entirely hollow, because if it were entirely hollow, it might not be totally, it might not be strong enough for your needs. So for instance, if you drew a cylinder and we're looking down on it from the top, the 3D printer might say, okay, we know that you've got a cylinder there, but we don't think you really need an entire cylindrical block of plastic. Instead, what we think you want is you want the outer wall to be solid. So that'll all be solid there. And then inside, you don't want it to be completely hollow. You want to have some structure there. So there will be something called an infill pattern, where the slicer will say, okay, we think we'll give you a pattern that looks kind of like this. if we're looking down on this from the top, it would be, something like this. It might have lines that go that way and lines that go this way. And something like that. And when you are setting up your 3D printer, you can choose how this happens. So you can specify things like the pattern that you want in the middle. So you can make it squares or hexagons or other shapes like that. You can also specify the percentage that this is filled in. So you could have very thin lines, and this could only be maybe like 10% full of plastic if you want your part to be extra light. Or you could say that maybe you want 40 or 50% infill, in which case these lines become very thick, and your part gets much stronger, but it also becomes heavier and it takes longer to print and it's more expensive because it uses more plastic. So you can specify the shape of the infill and also the percentage. So those are some of the main steps when you're slicing. The other thing is that you need to determine whether your part needs any supports. Okay? So if we're going back to this mushroom that I showed at the beginning of class, say we're trying to make this on a 3D printer. Well, we print the first layer on the bed, and that's fine. Then the second layer goes on top of the first one, and so on. We're doing great. We're coming along here. Each layer is going on top of the next one. That's fine. Until we come to this layer right here. So this layer is fine because it sits right on top of that layer. But what about here? What happens if I try to print a layer like this on a 3D printer? Yeah, exactly. The part out here is going to fall down because it's got nothing to hold it up. All right. So if you just try to print that, it would just fall down and it wouldn't work. But the 3D printer is aware of this problem, and so it can actually add in supports. And so supports are these sort of thin little columns that might go up like this, that would be printed as well, that could hold up your part. So if you tell the 3D printer that you want supports, it will go in and the slicer will add these extra little pillars to hold up the parts of your shape that extrude out and that would otherwise fall down. Okay? And then typically these supports are fairly small and relatively weakly attached so that it's easy to break them off after you're done. And yeah, they can just fall away. So the slicer figures out the shell for your part, it figures out the infill, figures out whether you need these supports. And then, after it's determined all of that, it goes in and it looks at what each layer of your part would actually look like. So it figures out that this bottom layer should actually be, a cylindrical outer shell with this much infill, and we're going to add these extra support things there. So it figures that out, and then it creates. So it does that for each layer of your part, and then it creates a pattern that the printer head is actually going to follow. So if it knows that the bottom layer looks like this, it actually has to figure out that, okay, the printer head is going to start right here, and then it's going to go back and forth and back and forth and back and forth like this to make the outer rim, and it's going to go all the way around like that until it gets around to the other side, and then it's going to come over here and make this part. And so it actually has to figure out exactly how to move around the entire thing to make each section, each part of that layer. Okay, and that's called the tool path, and that is usually created in a language called G-code. So this G-code is a machine language that tells the machine how to move and where to go and how fast to go and things like that. So the slicer will create the G-code for that part, which is really its own program that tells that machine exactly where to move to create that part. Okay. And so many of these characteristics can be controlled in the printer settings or the slicer settings. So when you go into the slicer settings, there will be a place where you can specify the pattern for your infill, the percentage for your infill. You can specify whether you want those supports or not. All those types of things. Okay. So then after you have sliced the part, you just tell the printer to print, and then it goes and actually does it. So that's the main process for 3D printing. So are there questions about that? All right. So then, hey, let's go on and do a preview of today's lab, and we can see how we're actually going to make your own 3D printed part. So I mentioned that I actually designed the engagement ring for my wife. So this is actually a picture of that. So, so this is a cross section of the ring. This is what it looked like. And then when it was actually cast in metal, it ended up looking like this. So it's a pretty cool process, and you can do some really neat custom stuff there. So the goal for today is to end up with something like this. Okay, it doesn't have to look exactly like this, but this is the general idea. You will have a name tag that has your name in it somehow. And I encourage you to be creative, okay? This is just there are very few specifications for this name tag. The specifications are here. It should fit within a dimension, a box that's 2 inches by 3.5 inches by 1 inch. It should include your name, and it should use some non-standard material. So I would go here and I would just change the material to, something that looked kind of cool. That's the goal, but I encourage you to be creative. So, we'll talk about some ways to do that, but don't make it look just like this. Make it look cool. Make it personalized. This is going to be your name tag. You want to show this off, so put a little thought into it and make it look cool. Make it look like something you'd want to show your friends and family. Okay, so that's the goal. So let's talk about how we can actually do that. So we'll create a new part here. So this is standard. This is, making a part the way we've been doing it the last 2 days. So we're going to start with a 2D sketch. I'm going to start with just a rectangle here. And then I'm going to make this rectangle the size that I want it. Now, I could just make it any size if I want, but another way to do that is to actually type in the numbers that I want. So right now you can see that over on the right-hand side, the number is highlighted. So you can see over here, this 0.324 inch is highlighted. So if I want, I can type in what I want that dimension to be right now. So say I want that to be 1 inch. I just type in 1. And then if I hit Tab, now I'm moved over and I'm entering the, you can see that the other dimension is now the other dimension is now highlighted in blue. So I can put in a number that I want there. So say I want 3 inches there, I just type in 3 and I hit enter. All right, and now I've got my rectangle. I can finish that. And then I'm going to extrude it just like before. And you can specify whatever distance you want there. So 1 inch is fine here. And now I want to actually get my name on there. So the way I'm going to do that is I'm going to do another 2D sketch. I'm going to click on this face. And then I'm going to use this, this text menu up here. So I'm going to click on text and then draw a box. And I'm going to put in my name. So I'm going to say Jordan Meyer. So you can see that it put my name on there, but it's kind of not great because it's been rotated around. So I don't want it facing that way. I'd like it kind of facing across the block. So what I'm going to do is I'm going to click on this rotate button up here at the top. So the first thing it asks me to do is to select what I want to rotate. So I'm going to click on my name here. All right. And then the next thing is that it asks for a center point. So I'm going to click the point where I want my name to rotate around. Doesn't really matter exactly. And then the last thing is I'm going to sort of move this around until it's in the correct orientation. And you notice that when I get close to horizontal, it kind of snaps to that horizontal position, which is what I want. So I'm going to click there and then say done. Oh, come on. All right, so what happened there? So let's try that again. So I'm going to rotate, I'm going to select that, and then the center point will be there. Yeah, I guess so. So let's try this one more time. All right. It's not, why is it not doing this? All right. Let's try this again. There we go. So, what the hell? Okay, it was freaking out. I think it rotated, but the display just didn't update or something. Anyway, all right. So I got my name there. The other thing that I can do is I can change the shape of that text box. So right now it's tall and narrow, so my name is kind of one name on top of the other. But if I want, I can make that text box wider so that my name can stretch out side by side. And then I can drag my name around and move it where I want it. And the way I do that is yeah, I click on it and then I just drag it where I want it to be. And then the other thing is I can change the size and the font. So in order to do that, I have to select my whole name and then click on the size up here and change that. You'll notice if I just have the cursor here and I change the size, my name doesn't actually change size. I really have to select the whole thing and then put in the size I want. And I can type in numbers that aren't available in the drop-down. So the drop-down only goes up to 0.24, but I say I want something bigger. Say I want 0.6. I can just type that in, and now my name is bigger. And it looks kind of weird in this display, but it should still, yeah, it still fits there. So obviously that's a little bit too big because it's going over the bottom of my thing. So I can make this smaller. So I could make that 0.3, say. And then the other thing is that I can change the font. So right now I'm just using kind of a plain font here, but I can go in here. Again, I have to highlight my name, and then the font is up here. So Tahoma is what I'm using right now. It's kind of plain, but there are all these other fonts that you could pick from. So we could pick Franklin Gothic, also kind of plain. California. So yeah, you can pick any font that you want. And then when you're happy with it, you can say OK. And then you can see that that font is updated there. So then we're going to go and finish that. And then we're going to extrude this. So just like before, we click on extrude. Now we have to select the profile that we want. So we're going to click on the name. And you can see that it pops out. And you can select how far you want that to come out. And you can also, so you can have it pop out like this, or you can have it go in and be kind of etched or recessed into your face. So if you want to do that, you could cut this, and you could have that cut down into your part. So I could say OK there, and then this is actually cut my name down into the face of that block. Okay. So that's a basic way to do it, but like I said, I encourage you to get creative here. Go wild, you know, make it look cool. Do something fun. Yeah, make it your own. Okay. So that is the basic block, and now I want to show you how we go from this 3D model to something that can actually be printed. Okay. So first of all, we're going to save this. You can save it on your student drive. I'm going to just save it on the desktop because I know I'm not going to want to come back to this, but I encourage you to save it someplace more permanent. So this will be name tag. All right. So now that I've got my part saved, I want to actually export this. So I'm going to go File, Export, CAD format. And we're going to choose an STL format. So this is what you want. And then you also have to click on Options down here, and you have to change the units to inches. Okay? So you want to export this in inches. And we'll save that. So now, if I go to my folder, which is the desktop here, I should see two files. So I've got this name tag part, which is the 3D part that I created in Inventor, but I've also got this name tag.stl. And this is the file that the 3D printer can actually understand. So this is the one that we really need for 3D printing. So when you have this name tag.stl file, that's what we're going to send over to the printer. So let me show you the printer software now. Okay, so this is the software that we're going to use on the printer in the back of the room. So this is a program called Repetier Host, and this is the software that allows you to position things on your printer bed and also to slice the files. Okay, so when this program first opens up, it's already got a part there on the bed. We don't need that, so we're going to get rid of that part. And now we're going to place our part. So I'm going to add an object here, and I'm going to find that part that I just saved, that nametag.stl. And I'm going to plop it down. Oh yeah, so that doesn't look quite right, huh? That looks way too small. And so I'm going to get rid of that. The reason is that I didn't set up this printer software yet. So this printer also has settings. So up here, there's units of imported objects. We need to change that to inches as well. So we exported our part in inches. We need to import it in inches as well. So we did that. So now we'll go back to this name tag file. There we go. So that's better. So now this name tag is right in the middle of our printer bed. But it's not quite right because the name is kind of facing to the side. And if we have the name facing to the side, it probably won't print very well because you're going to have some unsupported areas there. So what we want to do is we want to rotate this around so that it's lying flat on the printer bed. So what I can do is I can come up here to this rotate objects. And now if I look down here in the bottom corner of my screen, I can see these little axes there. So the red is X, green is Y, and vertical blue is Z. So up here, you can see that you can rotate the object around these axes. So when I'm looking at this, I want my name tag to kind of flip around and rotate around the X axis here so that it's lying flat. So I can come up here to X and I can go plus 90, and that flips it around that axis and makes it lie down flat. So now my name tag is lying down there flat, and it's right in the middle of the bed. And that'd be great if I was just printing this one name tag, but I might want to space it, move it around if I'm going to be printing more than one thing at the same time. So the way I can do that is I hold down the Alt button and drag this around, and I can place it wherever I want it. So I can put it off to the side so that there's room for other people's parts on there as well. Okay? So that's how we place the object on the bed. And then to slice it, we come over here to the Slicer tab, and then we can click on Slicer. And on the actual 3D printer, I would load some printer settings. But for right now, I'm just going to click on the slicing button. It shows the progress. And now we see a sliced version of the part. Okay? So it's a little bit hard to see, but the name tag is there, and it's been sliced. So it's been sliced up into all these little tiny layers. So what we can actually do is we can actually look at each layer, or a range of layers if we want. So right now this is the very first layer that we have there, and we can see how this will actually look as it's getting built up. So if you look carefully there, you can kind of see the infill pattern. So you can see that infill shape that I was talking about earlier. And so you can see this infill kind of keeps going up and up and up as we go along. But then at some point, we start to see the name being created in there. And then you can see just the outline around the letters where they are, and still the outer shell of the part. And then as this goes all the way up, we can see the top layer of the part there, and that's what the finished thing will look like. Okay, so this is how the part gets sliced. If you're curious, you can actually see the G code for this part. Remember, the G code is the program that tells it tells the printer exactly where to go. And so we can click on Edit G code, and you can see this is the actual code that tells the printer every single move to make. So it sets the temperature of the bed, it homes all the axes, it lifts the nozzle and so on, and then it moves around to all of these places to actually print that that part. Okay, so that's the G code. The print preview also shows the amount of time that it thinks that this print is going to take. So this is going to take about 57 minutes and 40 seconds to print this part. It shows how many layers there are and so on. Then the other thing that's possible with this program is you can manually control the printer. So you can do things like set the bed temperature. You can turn the extruder heater on and off. You can turn the fan on and off, and you can even move the printer around. Okay? Right now, all of these are grayed out because we're not connected to a printer, but on the printer itself, when these things are hooked up, you would actually be able to control all of these things. Okay? So that's how we actually do the 3D printing. So, so are there any questions about that? Okay, well, so that's what we're going to be doing for lab today. So, yeah, so I will take attendance, and then I'll let you have a short break, and then we can get started on making our actual name tags.